Okay, so humanity is heading back to the moon in a huge way. And I mean, this time we're planning to stay. We're talking moon bases, science stations, a whole new era of exploration. But all this incredible progress, it comes with a hidden challenge, a kind of cosmic cleanup problem that we really need to figure out before we get there. So, what do you do with a dead spacecraft when there's literally nowhere to bury it?
To give you an idea of just how busy it's about to get up there, space agencies and private companies have more than 400 moon missions planned for just the next 2 decades. 400! That's a mind-boggling amount of traffic for our little celestial neighbor. And yeah, this brings up a really crucial question. All of these satellites, all these landers, they all have a limited lifespan. So what happens to all that amazing high-tech hardware when it finally runs out of fuel or, its job is done? Where's it all supposed to go? So here's what we're going to break down. First, we'll look at why the moon is suddenly the hottest ticket in the solar system. Then we'll get into the galactic garbage problem this creates and explore the pretty ingenious solution people are working on, a lunar graveyard. We'll even discover a surprising scientific silver lining to it all before asking what this really means for our future on the moon. All right, first up, let's dive into this new lunar rush hour. And I'm not kidding, this isn't just a few isolated missions here and there. This is a full-blown international race to set up a permanent presence on the moon. So what's driving all this? Well, it's a mix of some seriously big ambitions. You've got major players like NASA planning their Artemis base camp and a joint base in the works from China and Russia. People are talking about future mining operations, and of course, scientists are itching to build super-sensitive instruments on the surface. And to make all that work, you need infrastructure, right? That's where things like the European Space Agency's Moonlight constellation come in. It's basically going to be a GPS system for the moon. Now, with all this incredible activity, we run smack into our main challenge. What do we do with the leftovers? And this isn't just about being tidy, you guys. This is a serious safety and logistics issue. The whole problem really boils down to one huge difference between Earth and the moon. See, back here, when a satellite gets old, we have a pretty standard way to get rid of it. We just let it fall back to Earth, where it burns up harmlessly in our atmosphere. It's like a cosmic incinerator. But the moon, it doesn't have that luxury. No atmosphere means the only real option for a dead satellite is for it to crash right into the surface. An uncontrolled crash could be absolutely devastating. Just imagine a piece of hardware that weighs tons slamming down near a priceless historical site, like one of the Apollo landing zones. I mean, those first human footprints. They're a treasure for all of humanity. We have to protect them. And it's not just the historic sites. Think about the science. These satellites aren't just going to gently float down. No, they slam into the surface at something like 1.2 times miles per second. The vibrations from that would be like a localized moonquake, and it could totally ruin the delicate data that any nearby science experiments are trying to collect. And the damage doesn't even stop there. An impact like that carves out a huge scar and kicks up a massive cloud of that super abrasive lunar dust. That stuff can travel for miles, potentially coating solar panels, jamming up equipment, and basically blinding any telescopes we build up there. So facing this problem, space agencies aren't just, crossing their fingers and hoping for the best. They are actively designing a very practical, if maybe a little dramatic, solution. Designated spacecraft graveyards. Researchers looked at a few different options. I mean, you could try to fly a satellite off into orbit around the sun, but that would take a ton of expensive fuel. Or you could move it to a stable graveyard orbit around the moon. But that's really tricky because the moon's gravity is all lumpy and uneven. So when you weigh all the options, a planned controlled crash is just the most practical and cost-effective way to go. And the plan itself? It's actually pretty simple. When a satellite's mission is finally over, operators back on Earth will use its very last bit of fuel to steer it towards a pre-selected remote part of the moon. Then they guide it down for controlled impact, making sure it lands far, far away from any historic sites, science experiments, or future moon bases. And hey, this isn't just some wild theory. The experts in the field totally agree. Ben Hooper, who's a senior project manager for a big upcoming lunar satellite, puts it really simply. Setting up these graveyard zones is just the most practical solution. It's all about being responsible and keeping the rest of the lunar surface safe for everyone who comes after us. Okay, but this is where the story takes a really fascinating turn. It turns out that intentionally crashing spacecraft into the moon isn't just a way to take out the trash. It's actually an incredible scientific opportunity. To get how, we need to talk about something called seismometry. The easiest way to think about it is like a doctor using a stethoscope to listen to your heartbeat. Well, scientists use seismometry to listen to the vibrations from earthquakes, to map out what's going on deep inside our planet. And guess what? The same idea works for the moon. And that is what makes every single one of these controlled crashes a perfect seismic experiment. Think about it. Unlike some random meteor hitting the surface, scientists know the satellite's exact mass, its precise speed, and exactly where it's going to hit. They're creating a vibration with completely known variables. It's amazing. As Professor John Zarnecki puts it, when you have an object where you know the mass, the shape, and the speed hitting a known spot, well, that's just a fantastic experiment. Every single impact becomes another key data point, helping us map the moon's interior in a way we've just never been able to before. So as we start to wrap this up, let's just pull back and look at the bigger picture this solution paints for our future out there in space. What started out as a really significant problem, the risk of turning the moon into a giant junkyard, has been transformed through some really clever, proactive planning. We're turning a garbage disposal issue into a unique, large-scale science laboratory, where every time a mission ends, it actually helps us begin a whole new chapter of discovery. This whole thoughtful approach to lunar graveyards is a fantastic first step, but it really points to a much bigger question. As we start to venture further out into the cosmos, how can we make sure we are being good ancestors? How do we leave these new worlds as pristine and as full of opportunity as we found them? It's something to think about.